Hello, everybody. It's my pleasure to be here in IP-SoC in Grenoble this year. And I'm here to introduce to you Sansa Security. First, a few words about myself. I've been with Sansa for like 5 years. But actually, probably most of you have not heard about Sansa for the last 5 years. And I will actually explain to you why. Because Sansa Security is a new name for a company which is already in the market for about 14 years. We were Discretix Technologies until more or less last week. So maybe some of you have heard about us in our previous name. The good news is that the company is the same company. We were not bought by anyone. We were actually not changed, only growing and increasing our business in the world. And mainly the reason and the reasons for this name change are coming from our focusing towards IoT. And of course, don't crucify me for using the term IoT. I will explain what I think about it very shortly. But basically, just to introduce to you first who is Discretix or Sansa Security for now. We are an Israeli company. We have been established in 2000, and the main goal of the company was to give solutions for security in SoC. And actually, within the years, it is also diffused into the software area. So we actually provide a complete solution, which is a subsystem, security subsystem for silicon, plus some software. I will give you some more information about very shortly. Just to let you know that we have headquarters in Israel and 5 branches, mostly in Asia and the USA. We have top-tier customers, SoC silicon vendors that are using our security solutions for quite a lot of years. We have done this change of rebranding the company, mainly aiming towards IoT market, which is actually a place where we were already active for a long time, but the focusing on the company and the strategy of the company right now is to go towards IoT with more focused offering. A few words about who we are and what is the offering. So what Sansa is offering? Sansa is offering security, silicon IP, and is accompanied by firmware, drivers, and everything which is on top of that. And we also also offer things that are actually working with our silicon IP, like different types of applications. These applications can also work on other silicon IP of other vendors. So if we are talking about a general platform, we look on the platform security. It is one part that we provide. And we look about applications that are connected either to our IP or connected to other vendors' IP. We have a unique solution, which we call Cloud Key, which is a provisioning tool that is able to provision the silicon, even when the chip is already out in the market, by providing in a secure way new keys, exchanging different secrets with the device in a unique way, which keeps the safety and the security and the authenticity of the device towards a server that we also provide. So just before I'm going to talk about the main topic of this speech, what we offer in Sansa Silicon is not just cryptographic engines or something like cryptographic IP that might be quite useful in the market, but we actually offer a complete subsystem, complete tool chain or a suitcase full of different goodies that we provide. I will elaborate a little bit about it at the later part in this discussion. So we're facing a challenge. We call it IoT. And as I have been hearing for the last 2 days here, no one likes the term IoT, neither do I. It's very easy, it's a very catchy name, Internet of Things. What are things? Internet we know, but what does it mean? A lot of people before me already explained that. I'm going to repeat some things that my predecessors had said, but it's quite clearly. It's a huge segmented market. So many different fragmentations of different technologies, use cases that can be implemented. Actually, any device which is connected to the internet could be thought as Internet of Things device or IoT device. diversity of different characteristics of those internet or IoT devices. Could be in the processing power, energy budget, communication, and so many, many more things. We actually think there is a standard. There is a bunch of standards, many standards, but there's no standard for this thing. I don't think there will be any standard for this thing, for IoT. And of course, there's one thing that everyone agrees upon. If you want to be connected, if you want to run services that are connected to the internet, you must have security. Just look very quickly on the diversity of different IoT devices that we identify. Of course, there are many more, but just in the automotive industry, industrial, smart grid metering, smart home, healthcare, and many, many more different types of market segments that will introduce devices that are considered to be IoT. Many technologies are involved in their hardware, processors, MCUs, smaller, larger, different software that is running on the CPU, different communications for these private area network that we are different gateways that are accumulating small sensors into one stream towards the gateway. Management applications, cloud and big data. It's a huge, huge, huge thing that very difficult to cover. Definitely not in the next 25 minutes still left for this. But just to count very briefly, for example, communications. In some cases, we will need to use cellular. This is very expensive, consuming a lot of power, a lot of energy, and the networks are expensive. So we will minimize that to the lowest necessary. We will use Wi-Fi because it's very much available. But again, it's not very good in terms of being energy consuming. It is quite a lot of energy in Wi-Fi. So we will prefer using lower power technology like Bluetooth, either better low power Bluetooth, or even NFC when it's available, when it's near enough. If you look on standards and alliances, there are tons of them. I'm not going to count you this list, but in very principle, as I said before, no standard, no single standard, many, many standards, and the market again is diversified on technologies, on use cases, and also on the standards and bodies that try to make some order in this market. So let's go to the topic of my speech here. And why do we need security? Why is security so essential in IoT? Actually, everybody understands that. I will just, give some highlights, some ideas around it, to emphasize the understanding that every device which is connected to the internet has to have some level of security that will protect it from malicious actions that are done by unauthorized people or computers. So let's take as an example. Yesterday was a fantastic short clip about some cars that are running in the traffic with perfect order. What we see here is a vehicle to V2X communications, perhaps a very good way how to manage all the cars that will not, to avoid collision and to make them run correctly. But just think about the tremendous risk if anybody is managing, to manipulate this system. For example, imitate that he's one of the car while he's not one of the cars here, and tells the computer or tells the system that runs the system that he's driving straight forward, while in reality the car that he thinks he is actually taking a left turn. That could be very bad. Even if you don't look on a picture like that, just think about a highway, and somebody has managed to plant a virus in one of the top brands that can actually drive without intervention of the driver, and at 12 o'clock turns all those car models to the right-hand side, no matter where they are or how fast they go on the German Autobahn. That could be a disaster, of course. So if you think about this kind of ideas, this kind of risk, it's surely that we have to be sure that every device must have trusted identity, trusted integrity. No one can manipulate the software that is running inside. Communication must be secure. Nobody can imitate it. Nobody can challenge the communications. Nobody can actually even tap the communication to take the secrets that are being communicated between different devices. All the assets, keys, passwords, and so on, has to be all the time protected, so no one can get his hand and imitate and take the place which he's not. And this system must be robust. It means that not only that you can't do that, well, the device is already in the field, but if you take this device and try to take it apart, do reverse engineering, trying to do something, well, you have the device in a fantastic lab, you still have to have no one be able to break this solution security that is tailored around it. So let's apply some security on our device. Okay, as you can see from this nice picture, it's probably you can apply any level of security that will protect you from any kind of threat that you have. However, as I'm sure you can also realize from this nice picture, that not every device needs the same level of security around it. And actually, being a security company, it's always to wait and to assess what is the threat and what do we need to protect. So actually, not one size fits all. We have to assess what is the potential attack and how much we need to protect ourselves from. And in the same time, we have to take some level of risk. And of course, this level of risk will be changed. If it is a thermostat in our home, then we need to protect that nobody will raise the temperature to 30 degrees while we don't want it to. But it's less risky than manipulating the old Daimler-Benz cars in Germany or spaceships, I don't know. Yeah. So in this way, we should actually classify the risk and classify the protection that we need to apply. So we build a threat model. It's a relatively simple one that actually talks about what kind of devices there are that are considered to be IoT/devices are there in the market and how much we need to protect them. For example, a very, very simple is software attack. You know, we all have PCs, we all have viruses, we have antivirus running there. But what is the damage that they can create? They maybe can steal some information, maybe they can interfere with our life, and we have some ways to protect ourselves. So relatively, in most cases, this would be considered as a low risk, a low threat to ourselves. Communications attack, man in the middle, snooping and tapping, could steal your passwords, could steal your credentials, and create more damage. If you go higher to some smart meters, industrial controllers, automotive ECUs, these are very, very sensitive areas. You don't want, as I said before, a car to collide. You don't want somebody to be able to steal electricity from the electricity company. These are things that you have to protect in much, much stronger way. So you have to protect against any kind of non-invasive probing. The last one is the invasive, is when somebody is trying, to open the chip. This is not a place in the market that we are residing in, but we actually cover all the first three in this list. Again, to the classification, the simplest one, Class A, limited threat model. It's a closed system running with either Linux or some RTOS. User is not a threat. I'm not going to manipulate my thermostat at home. User is not a threat, and actually here we have to apply the lowest level. Class B, the higher value, like the middle one, when we have, for example, a smart meter. Here, user can be a threat. I mean, I have a smart meter. Actually, I have a very good incentive, to manipulate my smart meter. I don't want to pay electricity company or gas company or whatever, which company, the amount they want. I want to pay half or nothing or put it on my neighbor or whatever. I don't want to pay. So I am a threat. So it has to be hack-proof against anyone. So, and it is running in a way that it has to be to protect itself and run the software in place which I cannot do anything with it. What does it mean and how do we do that? And of course, there is another security classification, open systems, like mobile devices, like this nice watch that you can actually download application to. Open system is more dangerous. The level of risk there is higher because anyone can actually download its own software to run on it, and it makes the protection more complicated. Of course, it's possible. So we see that most of the devices that are there today are lacking the ability to protect themselves in a good way. Usually, they are in many types of the lower range IoT devices, we find out that they have very minimal, if at all, set of protections. And this is something that must be changed in the next couple of years. So we're going to see what kind of protection means we are providing in order to create protection on these different levels of IoT devices. And I'm going to refer to a product that in Discretics we are having for many years. This product is called CryptoCell. Maybe we will also change its name right now. But in fact, this is a complete subsystem that I described to you before. It's my suitcase that you've seen before, which is able to provide security. And because it's so flexible and because it is very modular, we can apply it in different levels for different applications. We can do that on smaller scale. We can do that on higher scale. What does it include? It actually includes different means. So all these blocks, and I'm going to be very brief about that, each and every block here actually refer to something that we provide. We provide hardware. So hardware means RTL, silicon IP, that we provide to the manufacturer of the chip to integrate within its system. It starts with the very simple things like cryptographic engines that everybody else already have. We have a very big variety of cryptographic engines with a lot of flavors, correspond to a lot of standards, small, fast, low gate count, high gate count, and more performance. So in that way, we cover very large scale of different applications that are requiring cryptography. But this is just a tool for us in order to create this protection for the platform that we are running on. So in order to create protection to a platform, first of all, we need to distinct the platform from any other platform in the world. We need to create it what's called hardware root of trust. To create the hardware root of trust, we have this TRNG, which is there somewhere. It's RNG. Okay. Yeah. So our RNG is a TRNG. It's only a software-based RNG, not sensitive to the process, can run on any system. We provide it as an RTL. It is a very nice unit that we also provide as a separate core. This RNG creates the hardware root of trust. It creates the unique device ID by doing some manipulation of it. Unique device ID allows us to create the private key exchange with the different devices that we want to include, the different services that we want to include. It allows us to encrypt the image of the software that is running on this SoC and store it in a secure boot in a way that no one else will be able to manipulate this image and change anything which was not signed by the authorized signer. We are able, with this hardware root of trust, to create an external memory, a secure memory, a secure storage that is actually any flash, any type of memory, even a hard drive that is residing outside the chip, but is closely tied to the chip and exchange information only when it's encrypted. And it's encrypted with the credentials that were coming from the specific chip. On top of that, we have other services. Of course, we control the life cycle of the chip in this way. We apply different policies when the chip is in production or when the chip is after production, and we can also change it reversely if the device is coming for RMA and we need to do something. We block all JTAGs, but we have a policy that can allow access to the JTAGs, so we can actually do maintenance on the chip after it's also in the field. And we have also other features like, and this I have a separate slide for, the ability to do some provisioning when the device is already out there in the market. We are building this. Let me go one step back. This is just a functional, of course, a block diagram. Each and every block in here appears in many flavors, as I said, fast or slow, big or small, depending on the application. When we are approaching IoT according to the classification that I have showed before, we tailor the solution to match exactly what the customer is looking for, what kind of protection is required based on the threat model, based on the level of the sensitivity of the information that we need to protect, etc. When we do that, we actually tailor a complete system that we provide as an RTL to a customer, and the customer integrate it with the chip. For example, we have now working on and almost finished to apply a solution which is tailored to run in the Apple HomeKit according to the Apple HomeKit standard, in which they have introduced some new encryption flavors of Diffie-Hellman that is unique for this. So we have done these adaptations in order to fully comply with the requirements. So everyone who wants to build a device that will be in full compliance with Apple HomeKit will be able to protect this device utilizing the Sansa crypto cell. We have a secure provisioning and feature activation asset that is on top of the crypto cell, and it's a unique solution that we are providing, which actually enable access to the chip at any level when it's still in the factory, but after it leaving the factory and go to the OEM, if it's in a service provider or even if it's in the customer. And in each and every level, we are able to inject new keys, new secrets in a secure way, which is tied to the device. And it is being all monitored by a provisioning server that we also provide for that. So it actually provides huge flexibility, especially when talking about small IoT devices that you want all the process to be fully automated. You can't afford putting someone to do provisioning for millions of devices that you actually wear on your hand or put on the wall in every room. So all this type of provisioning can be done in a very fully automated way using this cloud key solution. I'm almost done. I wanted to summarize. What I wanted to tell you, you already knew. Security is an essential building block in every IoT device. The architecture has to be determined during the design of the SoC. It's not a good idea to say, okay, I'll put some cryptographic engines in the plan and let's tailor around it with some software when we finish the design of the SoC. It's a very, very wrong way how to do it. It must establish the basics like hardware root of trust in order to create good solution and safe solution in the future. Good security design offer tools that actually make your life easier in the future and actually make the final device more versatile. The in-field provisioning, for example, allow in-field feature activation. You can apply device with diminished level of features. Customer decided he wants to pay more. You can over the air upgrade his device in full security, full safety, without anybody being able to take a box, go to some garage mechanic that know how to break it and how to change it, to open all the features that are buried inside. They are not operatable at that stage. So Sansa Security can be your partner if you're developing an SoC or if you're assisting developing an SoC of that kind that has this kind of requirements. I'll be very happy to answer your questions. We'll be very happy to provide more information, more specific information for any specific case that you want to raise.